Welcome and thank you all for coming. This is our inaugural Tech Talk. It's a new idea, something that we wanted to try to create an opportunity for faculty members to network with each other and also with other members of the community that had an interest in whatever the topic happened to be. Our inaugural speaker is Marty Hall. Marty is a former member of the EP faculty. He is also a past member of the staff at APL, and he is president of CoreServlets.com, and he goes around the world and does training in all of the topics, as you can see listed on the screen. He's the author of several very successful books, and I really don't think he needs much more introduction. So, without further ado, I'll give you Marty.
Oh, thank you, Eleanor. Well, I learned Java for the express reason of teaching a course here in the EP program. And so I was teaching a bunch of AI courses in the when Java was still, wasn't even in beta yet. And I was looking for another class to teach. And then so when Java was in beta, I got into it, and that's how I got into it. So thanks to EP was how I got into Java from the beginning. So I used Java since it was, before it was officially the first official release, and I've seen it evolve over time. And I want to talk about Java 8, which I think is the single most significant release of Java. Well, I suppose if you count the first one, but so I want to talk about two main topics: lambdas and streams. And we'll talk about what lambdas, function expressions, are, and what streams are, and kind of compare them to some other technologies and compare them to other ways of doing it in Java as well. As I said, I got into Java. The reason I got into Java was teaching the EP program before I did it in my real job. And hopefully by the end of the talk, this one-page summary will make sense to you. Probably will not make any sense now. And I was doing AI. I was a Lisp programmer, and I'm one of the few people in the world who actually liked Lisp. And I did a bunch of AI applications for DARPA, and I did a bunch of applications here at APL, funded by DARPA and the Army Research Lab, and similar sorts of organizations, and people doing functional programming for AI. But it kind of faded from the mainstream, and then I was doing Java for a long time, and so why add this kind of weird stuff back into Java now? Java is an object-oriented language and not a functional language, right? Well, I think one of the reasons is just people are used to it now. And nowadays, if you do web applications, you have to know at least two languages. You need to know JavaScript, because that's what runs on the browser. Now, Google and a few other organizations have come up with other languages that you write that compile to JavaScript, but still, in the end of the day, it's JavaScript that's running on the browser, and then you got to run some server-side language. And so web developers, anyway, already know two languages. And JavaScript, despite the name that's kind of sounding like Java, is more of a functional language than an object-oriented language. And so people are used to it. And people are just familiar with this idea. And I think so one idea I think that drove the rise in interest in functional programming is Ajax. When Ajax came around, everybody started doing JavaScript. And now Ajax is such an important part of web applications. Ajax is when you use JavaScript to talk to the server and update incrementally just a part of the web page without reloading the whole web page. Every popular site does that now. So a lot more JavaScript programming was going on. And then I think the other big thing was Hadoop. Hadoop and big data, really can be thought of more in a functional programming way than you can in any other way. And so those two things, I think, have really drove an interest in recent years in functional programming. And I think in the early days, people thought that functional programming was associated with weakly typed languages. But who was I talking? Oh, Eleanor, I guess, about ML. ML showed that super strongly typed languages, more strongly typed than Java, could support functional programming. Scala, strongly typed language, supports functional programming. And so, both strongly, if you're looking for Java, come in. And, let me look at JavaScript for a second. Most of the time, JavaScript and Java don't look anything like each other. But in this case, we'll do something in JavaScript, and then we'll redo it in Java and see it looks actually pretty similar. But in JavaScript, when you sort an array, you pass in the comparison function. And to me, that's a very natural way of doing it. It makes sense. We're going to sort things based on this function. And they said, OK, the function takes 2 arguments, and it should return 1 if the first thing should go first, -1 if the second thing should go first, and 0 if they're tied. And so that if it's a stable sort, if they're already tied, they stay in the same relative order. So this sorts the strings by length, and this sorts strings alphabetically by the first character. And if the first character is the same, like 2 and 3, both JavaScript and Java guarantee that it's a stable sort, and so the order that they're originally in, it should stay in. And to me, that just seems natural. I'm going to sort it based on this function. This is the comparison function, the way I want to compare the two things. I'm sorting based on comparisons. So it's just kind of, there's been a rise in interest in the industry in functional programming. Kind of harkens back to the old days when functional programming was so common. And so why now? Well, there's more interest now. But why this specific syntax of lambdas now? One is it's just shorter. And people were tired of anonymous inner classes. And anonymous inner classes in some ways were good. I was used to functional programming, and I was used to closures. So when Java 1.2 alpha came out and it introduced inner classes, I was like, yay, something I'm familiar with into Java. And then Java 1.2 beta came out, and inner classes were gone. I'm like, this is my favorite feature of Java 1.2. What did they do? So the Java community was a lot smaller then, so I wrote to the Java spec lead, and I said, what happened? In the alpha release, you had inner classes, and in the beta, my favorite feature, and in the beta release, it's gone. And he said, oh, yeah, we had it in the alpha release, and nobody understood it, and everyone was confused about inner classes, and we just thought it was too complicated, so we took it out. And I said, no. Well, it turns out that Guy Steele, the originator of Scheme along with Jerry Sussman, and the spec lead for Common Lisp, was a friend and colleague of mine, and he had just been hired by Sun Research Labs in Boston. So I emailed Guy Steele and said, hey, you're a big shot. Will you please email the Java specification lead and tell him we need inner classes back in the language? And then I had a couple of other colleagues, one of which was Peter Norvig, who's now the director of research at Google, and I'll tell you a story about that when I give the talk at Google. And said, you're also a big shot. Email the Java spec lead. And like 3 days later, I got email from the Java spec lead saying, enough already. Stop telling your friends to email me. OK, we'll put inner classes back in the language. And so inner classes, in principle, give you the same thing as functions and closures. In fact, that was one of the things Scheme tried to prove, that they fundamentally mean the same thing. But meaning the same thing and being as easy to use are not the same issue. And anonymous inner classes are just kind of big and bulky and cumbersome and tedious. And the this variable doesn't mean the inner class or the outer class, and the outer class named this weird thing and stuff like that. And you can't have non-final local variables and stuff like that. So make something that's more concise, easier to read. And if it's easier to read, it's easier to understand, it's easier to modify. Streams, in some ways, are separate. Lambdas would be useful with or without streams. Streams would be useful with or without lambdas. But streams are another big new feature of Java 8. And they're things that are designed to pass in functions. So this says, go down this stream and call this function on each member of the stream. You just make up a local variable name that's bound to each member of the stream, then it calls this function on it. And as I said already, people are used to it, especially from JavaScript and from big data. And we'll see that some people will argue that what they did in Java 8 is not true functional programming. There's not a real function type. There's not mutable local variables. People debate whether those are critical things to be real functional programming or not, but some people say that. And so what they try to do in Java 8 is also do something that doesn't preclude adding in those two features in the next release of Java or the release after that. We'll see if they ever do. I'm not so sure they need to, but they wanted to prevent that. So here's the idea. Take what you wrote on the top in Java 7 and turn it into the thing on the bottom. But make sure that under the hood, at runtime, they're the same. Not just the same efficiency, but actually the same thing under the hood. And the question is how? How does Java know that this funny weird thing at the bottom means the same thing at the top? And that's what the next few slides are about. Okay, so being concise is important because concise means it represents things more clearly. It has a better meaning, and so then if you this is the only part that really matters. All the rest of the stuff is just kind of boilerplate code. So if you can boil it down to the gist of it, it's more expressive. It's more powerful, it's easier to maintain, it's easier to modify. So being short is good. But I think that there's another issue. Oops, sorry. Which is functional programming is also a different style of thinking. Nobody's trying to turn Java into Scheme or Lisp. Nobody's trying to say Java is primarily a functional programming language. It's still primarily an object-oriented language. But there are certain topics, there are certain strategies, there are certain approaches, there are certain problem areas that functional programming provides a more natural solution. So that you want to get people to think in that way so that those kinds of problems can be addressed more easily. And then as I said before, streams are things that fit naturally with Lambdas, and we'll talk about that in the second half of the talk. Okay, I'm just going to skip this. This is all out now. Java 8 is final. Okay, so the idea, yes, sir?
Marty, back in the prehistoric times when you practiced procedural.
And I can repeat the question also.
Back in the prehistoric times when we were doing procedural programming, they used to you used to be able to write a method or a function without side effects. And to me, every time I hear people talking about functional programming, I keep thinking back to that writing a function without side effects. Is that actually the same thing?
Okay, so the question is, is functional programming and procedures or methods or functions that have no side effects tied hand in hand? And the answer is, I don't think they're necessarily tied hand in hand. I think functional programming means you can pass functions around. Now, there are people who say functional programming works better if the functions you pass around have no side effects. In particular, it's much more easy to parallelize them without worrying about race conditions. So there is a benefit to side effect-free functions, but I think the term functional programming means passing functions around. It does not necessarily mean that those functions are side effect-free. But there are some people who think, in addition to the benefit of functional programming in general, there's a benefit to trying to make the functions you pass around be free of side effects so they parallelize more easily. So the idea is that you're going to write something that looks like a function. All this stuff in red kind of looks like a function. This little arrow means kind of returns. Take a function that takes 2 arguments and returns the thing on the right. I think in Scala they use an equal sign arrow to mean returns. They use a minus sign arrow in Java. But they didn't change the API. Arrays.sort, this is an executive service for multi-threaded programming. This is an action listener, and this is something that I wrote that we'll talk about later. The API still is the old way. And so Java thinks that these funny, weird things that look like functions are the things that they used to be. That the top one is a comparator, and that this one is a runnable, and that this one is an action listener, and this one's an integratable. And the question is how. And the whole answer is keyed on one simple point. All of these methods, the argument in red is interface. And it's an interface that takes one method. Or more precisely, one abstract method. So let me take a little diversion and say something else about Java 8. So those of you who are Java programmers, which are most of you, does Java support multiple inheritance? No. Yes, OK. All right, so there's 3 answers to this question. One answer is no. Scott's answer is a little more finesse, which says, well, no, it doesn't support multiple inheritance of implementation, but it does support multiple inheritance of interfaces of types, and so you kind of have a little bit of it, but not the main thing. But usually when people say multiple inheritance, they mean of implementation. So no is the more common answer, but the more finessed answer is fine. But there's now a third answer. No until Java 7, yes in Java 8. So in Java 8, this is not the topic of this lecture, it supports real multiple inheritance. Interfaces can have concrete methods in Java 8. How weird is that? And so you can have real multiple inheritance with mix-ins. And then they have to solve the diamond problem. And what happens if you implement two?
Java just more like C++. The function already have pass function around in C++.
You cannot pass functions around in C++. You can in C#. You can pass function pointers around in C++, but it's not at all the same thing. So maybe Java and C#, I think, are continuing to follow each other. But I would say Java and C++ continue to diverge in overall capabilities.
So I don't really have experience outside of Java. When you say passing functions around, are you talking about it's passing whatever the function returns? Like, say you have a function that returns a data structure of an array. Is that what's being passed?
OK, so let me give you a quick example in JavaScript, because that's probably the language other than Java you in the room are most familiar with. So in JavaScript, I could do this. Function square. Now, JavaScript, of course, is a dynamically typed language. Java is strongly statically typed, does the type checking at compile time. Square of x, return x times x. OK, and then I could say var f equals square. And then I could say f of 5, and it will return 25. Or I could say var function double of x, return x times 2. Sorry for my handwriting here. Oh, my handwriting's bad to begin with, but when I'm stretching, it's really bad. I could say var funcs equals, use square brackets instead of curly brackets for arrays in JavaScript, double, comma, square. Notice, to answer your question, these are not function calls. These are function objects. The function hasn't been called yet. So it's not the return value. It's the actual function object. And then I could say funcs sub 0 applied to 3, and I get 6. Go into this function, go into this array, take that function, call it on 3. So I'm actually passing the function object around. You can do this in JavaScript, you can do it in Lisp, you can do it in Scheme, you can do it in Scala. You can do a little bit of it in in C++, but it's not the same. And we'll see that the Java way is not quite as rich as this, but has some other advantages. Where did I put my clicker? OK, so the key to how all this stuff is going to work, how it can work retroactively is the key. Of course, they could redesign Java and make it incompatible and put in function types, no problem. But then everybody would complain. The key is that those things in red are the same type they were in the API in Java 7. This is a comparator, this is a runnable, this is an action listener, this is integratable. So how can that funny thing that looks like a function object, how does it know that that's a comparable? How does it know that comparator? How does it know that that's a runnable? How does it know that's an action listener? How does it know integratable? And the key is the real API expects an interface, and the interface has one method, or more precisely, one abstract method. In Java 7, there's no difference between an interface with one method and an interface with one abstract method. They mean the same thing. But in Java 8, when you can have concrete methods and interfaces, they don't necessarily mean the same thing. So single method interfaces, or single abstract method interfaces, SAM, single abstract method interfaces, or sometimes they're just called functional interfaces. An interface of one method, one abstract method, is something that you can use as if it was a function in Java 8. OK, and so the basic idea is you make a call to an anonymous inner class, and you basically replace it with just the arguments in the body with an arrow in between. So let's give you an example here. Actually, let me mute this for 1 second. So here's what we would do if you had an array of strings in Java 7. String array words equals curly brace, hi, a bunch of other ones. And I wanted to sort them. I would call in Java 7 or Java 6 or Java 5, I'd call arrays.sort. I would pass in words. And then I could use an anonymous inner class with a string comparator. So I would say new. This is normal Java syntax, not new in Java 8. Comparator string. compare string s1, string s2. And then if I want to sort them by length, I'd return the difference between the lengths, s1.length minus s2.length. Curly brace. All right, so in Java 8, you say, well, the API already knows that that's a comparator. Although actually this is a genericized comparator, so it actually does some type inferencing to figure out it's a string comparator. It's actually a little harder than you think. But anyway, it knows it's a comparator more or less, so you don't have to say so. And it already the interface only has one method. So it must be public int compare. What else can it be? That's the only method there is. So you don't have to say that either. And then you put an arrow here and use that. That's the first cut. And that's the basic idea. You can do even a little better. We'll see in the next couple of slides, but this is the basic idea. Java already knows it's a comparator and already knows it's public int compare, so you don't have to say so. At runtime, it's still an instance of a comparator, and it's still, if you do a backtrace or set a breakpoint and step through the stack, it's still calling public int compare. So it's not some new object, and it compiles to the same thing. In fact, it's more efficient than the anonymous interclass was. But at compile time, not at runtime, that thing turns into what I wrote before, more or less. It's not actually an inner class. I mean, an anonymous inner class, but it's turned into a class that implements comparator behind the scenes. OK, so that's the basic idea. But it hinges on the idea that comparator is an interface that has one method, or more strictly in Java 8, one abstract method. If it has two methods, it won't work. OK, and then you can do a few other things. You can say, not only does Java know that it's a comparator and it's public int compare, it already knows that those types are strings. Now, that's actually harder than you think. It has to do some type inferencing on that to know that. But because it knows that, you don't have to say so. So you can leave that out. And you're left with that thing. Now, it is not dynamically typed. Java is still strongly statically typed. Statically typed means it's doing the type checking at compile time. It's still checking at compile time that that's an array of strings. And you're not going to ever have runtime type errors with it. In JavaScript, of course, you would, but not in Java. So it's not turning this into dynamically typed. It's just, it knows it's a string, so you don't have to say so. Then you can go one step farther and say, this is pretty short. It's just a single return statement. If you could express it as a single return statement, instead of putting the return, you can just put the expression. And you're left with that one, which JavaScript and Scala programmers, it looks exactly like you're used to. This is actually shorter than JavaScript. JavaScript, you would have said function. Except for saying function here, it's kind of the same. This is exactly like you would do in Scala. But it's behind the scenes, it's still doing what I wrote on the board originally. That's the cool part. They didn't change the underlying API. And it turns what looks like a function expression into the underlying thing at compile time. Not at runtime, at compile time. And there's one other tiny optimization that's hardly worth anything. But if remember, the interface has one method. If that one method has one argument, you can leave the parens off if you want to. Whoop-de-doo. Not much of a big deal, but some people like that. But not if there's two arguments. If there's two arguments to the single method of the interface, you got to put parentheses. If there's one argument, the parentheses are optional. If there's zero arguments, the parentheses are required. Only if there's one argument. So that's not a very important one. OK, so I would argue the bottom way is more expressive than the top way. And it's not just that it's less typing. It's that the top way, which is what we would do in Java 7, Java 6, Java 5, there's so much boilerplate code, it just kind of obscures what's really happening. But what do you do when you make a runnable? That's, if you're not a Java program, that's when you call a thread in Java. This is the code that it runs in the background. Well, what you do is that thing. So you should only have to say that thing. Call a function that takes zero arguments and does that. Or if I press a button, what happens when I press the button? It sets the background to green. So call a function that takes one argument and sets the background to green. And of course, I could use the argument in the right-hand side if I wanted to. And so it's not just less typing. It's more expressive. It's easier to maintain. It's easier to understand because you're only putting in the part that actually matters. You're not obscuring it with all this, well, all this other stuff. But the API didn't change. For an executive service, execute still takes a runnable. For a button, add action listener still takes an action listener, same as it did before. And this turns into that at compile time, or something equivalent to that, I should really say. OK, now we can even compare Java to JavaScript, which is kind of unusual. And the Java way is actually a few characters shorter than the JavaScript way, and I think equally expressive. You're basically passing in the sorting function. You're really passing in a comparator. But that's not the way to think of it anymore in Java 8. You say, I'm passing in the sorting function. Here's the sorting function. Takes 2 arguments, sorts them by length. Takes 2 arguments and sorts them by the first character or whatever. OK, and so the first point is shorter is not just less typing. It's more expressive, easier to understand, easier to maintain because you're focusing on the part that really matters. But the second thing is you can think of different strategies that wouldn't even occur to you to try if you didn't have functional programming. So those of you who've done Lisp and Scheme and ML and Scala and hardcore functional programming languages, you're used to this idea of higher order functions, functions that return functions. This happens all in JavaScript. People have to do this. That's why Ajax is so hard, because the XML HTTP request object can't be stored as a global variable, because if you press the button twice before the first request comes back, you override it. And so you've got to make this closure to incorporate it, encapsulate it, and nobody understands it. And so they have to use jQuery because they don't understand how to do it themselves. But even in jQuery, you've got to write closures. And so Java programmers that come to JavaScript are always miserable failures because they don't understand functional programming and certainly don't understand closures, but you got to do them. And so functions that return functions are common things in functional programming languages. But Java people would never even think of this. And so if you go back to here, you say, well, we're always subtracting them. We're subtracting something. So the real gist of it is not just a comparison function. The real gist of it is length. This one is looking at the difference of length. This one is looking at the difference of the the Unicode value of the character at the beginning, or sorry, at the end, starting by the last character. So you could have a higher order function. And this is actually now built into Java called comparing. This says, pass in the definition of a key. Given a string, what do I want? I want its length. I want its last character. I want its last character multiplied times 3 divided by 7, or whatever I want. The key. And this method call will then produce this lambda, which will then produce this object. And so functional programming people are used to this idea of higher order functions. Java people never even occurs to them. But that's a very powerful idea, functions that return functions. JavaScript people, of course, do this all the time. All right, let me ask you another question. This is for the Java programmers in the crowd. Where did I put the eraser? Here's another one. OK, let's say I write a servlet. Public class my servlet extends HTTP servlet public void do get All right, what's the purpose of that?
To generate a warning if you accidentally override something, indicate to the compiler that you intended to override.
OK, so those are the 2 reasons. There's 2 reasons for this. One is catch errors at compile time instead of runtime. That's why the dynamic typing of JavaScript is so dangerous for big projects, because you catch errors at runtime instead of compile time. So one thing is catch errors at compile time instead of runtime. So the actual method in the interface is doGet with a capital G. This is not the right method. if I left off at override, this would compile. Because doGet with a lowercase g is a perfectly legal method name. And then when I ran my servlet, I just get funny runtime behavior. Nothing would seem to happen. None of the code that I put in here gets getting called because it's in the wrong method. I mean to be overriding a lifecycle method. That's bad. Runtime errors are bad. Compile time errors are good in every language. So the first thing, as Scott pointed out, is this will catch errors at compile time. If this doesn't really match a method from the parent class that you're attempting to override, it won't even compile. That's a good thing. But if I do it properly with a capital G, it'll work with or without an override. You don't have to use that override to make it work. It's just a good idea. It's a very, very, very good idea, and kick anyone off your team that doesn't do it. But not technically required. It's just required unless you get fired. And the other thing, as Scott also pointed out, is you're just advertising to your fellow developers what's going on. Oh, by the way, I'm not inventing a new method. I'm replacing a lifecycle method in the parent class. So when someone comes along and maintains your code, they realize, oh, this is not just a new method. I don't have to search around to where the programmer calls it. It must be called by somewhere in the system because I'm overriding a method that came from the parent class. So it catches errors at compile time, and it expresses the design intent. Yeah, certainly in Eclipse, you can say if you override something and you didn't put that annotation in, you can do it. I thought that was an Eclipse thing, not a Java thing, but maybe it's both. And this is if you're an Eclipse programmer, you should always turn that feature on. OK, so but the point is, it'll work whether you do this or not. But it's a good idea. Catch errors at compile time instead of runtime, express the design intent. So there's a new annotation called @functionalInterface, which means I'm making an interface that can be used as a Lambda. What makes an interface usable as a Lambda? One method. If it has one method, it can be used as a Lambda. If it has two methods, it can't. So suppose you didn't use that annotation, and you put one method in it and use it as a Lambda. It worked fine. And then a developer comes along later and puts a second method in it. The interface would compile. The other code would now fail to compile, but the interface itself would still compile. Now, it wouldn't be a runtime error. It would be an error in a different class. But still, you'd like to say, this interface you can't add a second method to. So if you mark it with that functional interface, if you try to add a second method to it later, it won't compile. It'll say, hey, you wrote an interface that you're intending to be used as a Lambda, but you added a second method. It's not legal, a second abstract method. And secondly, it expresses design intent. It tells your fellow developers, hey, this is an interface for which I expect you to use Lambdas. So it's kind of an analogous idea, but it works whether or without you do it. And that's important because whether or without you do it, whether or not you do it, with or without the annotation. That's very important because all the Java 7 interfaces that have one method, you can use Lambdas for them. And they weren't marked with that functional interface because it didn't exist back then. OK, so here's something that people who do functional programming think is very natural. People who do object-oriented programming think is very unnatural and cumbersome. So you want to do some numerical integration. You want to evaluate a function and chop it up in a bunch of rectangles, or rectangles with little triangles on top, or something like this. In this case, I'll just chop it up in a bunch of rectangles and add them up, and hope that if my function is well behaved, the smaller number of slices, the more accurate estimate I get of the area under the curve. So I make an interface called integrable with one method. I can now use a Lambda for it, whether or not I do this. But by doing this, if they add a second method later, it'll fail to compile, and it expresses my design intent. This is an interface which I expect people to use Lambdas. And then when I do the numerical integration, this is just simple adding up a bunch of rectangles. This code is exactly the same as it would have been in Java 7. No difference. This interface, except for this annotation, is the same as it would have been in Java 7. And then I've got some test routines. But the calling code is different. That's where I pass in a Lambda. It's expecting an integrable, but I pass in a Lambda. Why can I pass in a Lambda? Because integrable is a method that takes integrable. I called it integratable for eons on all my slides. And then Kai Horstman, who is a co-author of mine, was reviewing it. And he's a math professor at UC San Diego. And he says, in math, it's actually called integrable, not integrable, not integratable. I said, are you sure? And he sent me a bunch of references to prove it, and I was like, drat. Had to go change all my slides. OK, so that, the API says it expects an integrable, but I can pass in a lambda. And this is where it's just so much more natural and readable. Integrate the function that takes x and squares it from 10 to 100. And this test routine does it with 10 slices, 100 slices, 1,000 slices, 10,000 slices, 100,000 slices, and compares the answer. Integrate x to the third. Integrate sine of x. Integrate e to the x. It's just so much more natural. And of course, you could do this in Java 7. But what you'd have to put here is this big, cumbersome, ugly, tedious, bothersome, anonymous inner class. And it's such a pain in the neck that people don't bother. But it's just so natural in a functional language.
Okay, so I guess let me get this straight. You can only use this little trick with classes that have one method.
Interfaces that takes one method, right?
And to invoke it, you have to have the little arrow, like.
Right. So basically, you're writing the body of the one method of the interface. So the one method of the interface takes a number and returns the square of it. That's the key idea.
And it has to be all done on that in the bracket, or not brackets, quotes. Parentheses.
If it's well, that's just because this method expects this argument in parentheses. I could also bind this to a variable. I could say integrable I equals some big long thing, and then put the I here. So any place Java expects a parameter or a value that whose type is an interface, and the interface takes one method, you can now use a lambda. That's the key idea. And you didn't have to change the underlying API to do it. Of course, you could make a new language that looks mostly like Java and has real functional types. Easy to do, but is not compatible with all the rest of Java. So the real trick there is how can we add in functional programming without breaking what already works in Java, and without changing the APIs. That was the real key, and that was the real genius of this idea. Okay, and I just think this is just so much more natural and easy to understand. This is the function that I'm integrating. Okay, and then you can say, well, hang on a second. X returns sine of x. This is the argument. This is really the body of the method of the interface. So the interface takes one method, and the one method takes a number and returns the sine of it. And behind the scenes, it still compiles to that real code. But x returns sine of x, x returns e to the x. Why don't I just put sine of x? And why don't I just put e to the x? Why do I have to write a method that calls it? And you can. So you can do this one instead of that one, and this one instead of that one. If you forget about method references, you got to know lambdas and streams to do Java 8. Because first of all, more expressive. Second, as we'll see in streams, much higher performance. And thirdly, everyone else is going to be doing it anyway, and so if you don't understand it, you can't write code, or at least maintain anyone else's code. But this one, if you forget about method references, you don't understand them, you don't understand why that works, it's only 4 lines longer to do this, and has the same efficiency anyway. But basically, this is saying, call an anonymous function that takes a number and calls sine of x. And this is just sine of x. So back to the JavaScript thing, calling f here is like the top one. I make a new variable that points at the old function, then call the new variable. Why not just call square? And so this is like just calling square, and this is calling a function that's bound to square and calling that function. Not much difference. All right, here's a question for you. Don't peek at my answer. What's the type of this thing in red? Everybody in the room who's a Java programmer, if you think carefully, can answer this question. Why do you say? Because the argument has to be integrable to be passed to integration tests anyway. So the answer is easy if you're not distracted. You look at the API, and the API just gives you the types of the arguments. And the API for integration test says it takes an integrable. But wait a second. I wrote integrable. How the heck did the Java designers math that sign as a built-in function? How did they know it was an integrable? They hadn't seen my code yet. Of course, the answer is they couldn't know. And so what type a lambda turns into depends on context. The same exact lambda can turn into different types at compile time, depending on the context in which it's used. So here's a quick example. I make 3 interfaces, foo, bar, baz. But all of them have compatible methods. Double in, double out. That means I could use a lambda for any of the 3, the same lambda for any of the 3. So I could do that lambda, that one, or write out the whole lambda instead of the method expression, and it would work in all 3 cases. But in the top line, either this one or this one, that thing or that thing turns into a foo. And in the second line, the exact same thing turns into a bar, and the third line, the exact thing turns into a baz. But it turns into it at compile time. And this is the one downside of the Java way. In JavaScript, when you make a function, you always know how to call it. You just put parentheses. You bind it to another variable, no problem. You still call it parentheses. You put an array, no problem. You still put in parentheses. But in Java, the code that uses the lambda, not the code that passes in the lambda, but the internal code that uses it, has to know the real method name. So this is not a real function type. Java 8 did not introduce a function type. In some ways that's bad, but the really, really good compensating good news is all the existing APIs still work. So some people say, well, you know, Java 8 is OK, but it's not real functional programming because you don't have a real function type. You don't have a type that you can bind to a variable, and anybody, any place can call it without having to know, how the interface is written. You don't have that. So is this functional programming or not? I don't know. Some people say yes. Some people say no. I say it's pretty darn good, whether it's real functional programming or not. OK, the next point is, why did I write the interface called integrable? Just so I could write a method that takes double in, double out. Because the calling code didn't mention that it was an integrable. It just used lambda. Double in, double out. And as we showed here, anything with double in, double out, I could use the same lambda for. And so a lot of the common cases are actually already built in. So, oops. So I didn't have to define an interface called integrable. I could just erase it. There's already one built in called double unary operator. Now, the fact is, it only is a one-line interface. And the name of the interface expresses the fact that I'm trying to do numerical integration, so maybe it's worth writing it anyway. But the point is, if you didn't want to write it, there's already one built in for a lot of the common cases. But the really, really, really valuable built-in ones are not the ones that contain a method with primitive types. The really, really, really valuable built-in interfaces, or built-in functions, are the ones that take generic types. That's what's so valuable, and we'll use it a lot in the second half of this lecture when we do streams. So let me give you one quick example. There's something built in called predicate now in a new package called java.util.function. And the way that interface was defined is the same way you would have written in Java 7. But the way you can use the interface will be different, as we'll see in a second. So it's called predicate. And you use a generic type. So that means you basically have a function called test that takes an employee in and it returns a Boolean. It says yes or no about some employee. Is this employee hired before a certain date? Does this employee have a salary or something like this? And the method is called test. All right, given this idea, let's write a method that, given a list of employees, finds the first one whose first name is Marty. If there are 2 Martys and employees, then it returns the first one. And as we'll see, we really should return an optional instead of a null, but I haven't introduced that idea yet, so I'll return null if it doesn't find anything. And if I told you, given a list of employees and a first name, return the first one that matches, otherwise return null, and you wrote this code, nobody would object. Code seems perfectly fine. Loop down the list of employees, check the first name, return perfectly fine. What's wrong with this code? And probably if I told you to do this and you wrote this, nobody would complain. Until I said, given a list of employees, find the first one whose salary is greater than a cutoff. And then you write this. Sorry, this. You see the problem here? What's the #1 main goal of object-oriented programming? Don't repeat yourself. What have I done? I've repeated myself. So this is not so great. So can we do better? And the answer is yes. Pass in a list of employees and pass in a test function. And return the first one that passes the test function. Okay, it's a very natural idea. And you could have done that in Java 7 too. But the calling code would have been long and cumbersome. That's the problem. So now in Java 8, you can write this code and you can say, oh, given a list of employees, find the first one that passes this test, otherwise return null. And this test is, return the first employee whose salary is greater than 500,000. I gave this talk at Google headquarters in Mountain View, and they kind of laughed and said, well, Marty, this doesn't really narrow the field very much. OK, well, fine. Other places it does, buddy. Find the first employee whose last name is equal to Marty or Hall or Smith or something like this. Find the first employee whose employee ID is less than 10 and really higher or something like this. And then we can do even better, and we can say, employee, 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 employee. Why don't I use generics and say T, 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 T? And of course you can. And everybody in Java 7 and earlier, Java 5 and later, had to know how to use list and map and all the things that already use generic types. But it wasn't super common for Java programmers to write methods of their own that supported generic types. But it's much more common now in Java 8. Because generic types and lambdas kind of go hand in hand, and the whole goal is don't repeat yourself. Make your code more reusable. And so now I can pass in a list of blahs and a blah predicate and return the first one that matches. Pass in a list of cars and a test that says, is the car's sticker price less than 50,000? Pass in a list of houses. Is the house's selling price greater than such and such? Pass in a list of employees and something about their employee ID. Pass in a list of countries and something about their population. Pass in a list of tables and something about their weight, and so on. And so, of course, all the old code still works, but now some other things work as well. Pass in a list of countries. Find the first country whose population is greater than this. Pass in a list of cars. Find the first car whose price is less than this. Pass in a list of companies. Find in a list the first company in the list that matches this. Pass in a list of strings and find the first string that passes this test, and so on. So the basic, most important, major goal of lambdas is make your code more reusable. Make it more expressive, make it more flexible. Don't repeat yourself as much. OK, and predicate was basically defined the same way you would have in Java 7. And the code in here is the same as in Java 7. What's different is the code that calls it. That's the one that can use the lambda. So the interface is the same. The code that uses the interface is the same. The code that passes in the interface is where you can now use a much more expressive and natural way. And you could have done this in Java 7, but the calling code would have been so bulky that you wouldn't have even bothered. It would have been more repeated code than we repeated back here with the salary and the first name. So you wouldn't have bothered. OK, so the interfaces are basically the same, except maybe for the annotation. The code that uses in the interface are exactly the same. It's the calling code that's different. The place where it takes an interface as an argument, you can now pass in the lambda if that interface has one method, exactly one method. OK, and there's a bunch of other ones as well. Function. So we'll see predicate in about 15 minutes when we cover streams, when we filter, remove all the things, keep all the things that pass this test. Function is from map. All you functional programming people use a map. It's built into JavaScript. It's built in Lisp. It's probably built in a Scala, built in a scheme. And so you do a transformation. And function will be used for that. Consumer is just call something that does a side effect. The forEach loop or forEach method that we'll see does that. Call this function on each thing. Binary operator is used by reduce. We've got map and we've got reduce, where you combine things. We'll see all of those examples in a second. So these built-in functions, which are really built-in one-method interfaces that support generic types, are super duper useful in Java 8. You could have written the same interfaces in Java 7, but they wouldn't have been particularly useful. OK, so on to streams. That's the really, really, really big features are lambdas and streams. There's lots of other new things in Java 8, but those are the big ones. most Java releases just augment the libraries or add some new libraries. But this changed the underlying basic programming model of Java. The old programming models still work, but it added some new really cool ones. All right, so on the surface, streams kind of look like lists. So why do we need streams if we already have lists? And why don't we just augment the list interface? Well, two things. One, cool methods. Two, cool features, cool characteristics. So you've got a map, you've got reduce, you've got filter, you've got all sorts of cool things. And as we'll see later, it would have been hard to put these, it wouldn't have been possible to put these methods into the list interface and give them the same performance, as we'll see. And secondly, they've got some cool features, kind of high-level characteristics that lists lack. The most important one is probably lazy evaluation. It doesn't really do all the operations you tell it to do. It only does the ones it needs to find the answer it thinks you need. Secondly, it can do it in parallel automatically without you having to write an executive service. And thirdly, with lists, you got to put real data in them. You can't make a list that says, every time you try to access something from this list, if it's not there already, go and call a function and make it. You got to put it in ahead of time. But with streams, you can put stuff in ahead of time, or you can have a generator function. Every time somebody tries to get an entry from the list, go and call this function, and then use that as the value. But it didn't really fill it in ahead of time. It only gives it to you as you need it. OK, so given an array or a list, you can turn it into a stream. And then you can do things like filter and forEach and find first and map and reduce. We'll cover all of these in a second. But all of them take lambdas. I'll explain the syntax as we get to it. But it's much faster and more memory efficient than it looks on the surface, and much faster and more memory efficient than the same thing would have been if you'd put those methods into the list interface. And that's what I want to illustrate. OK, so there's lots of different ways of building streams, but the basic way is you can wrap a stream around an array or list. Those are the two most important ways. Array or list. OK, so let me just cover 1, 2, 3, 4, 5 methods. There's tons more, but let's cover those 5. Give you a feel.
Why did they add that stream method to the list without breaking everybody?
I don't understand the question.
So it's go back to the slides. Right there where you. Yeah, this guy. SumList.stream. SumList, right. I assume, is
a list.
A list type.
Right.
So how did they add stream there without breaking everybody who implements list? OK, so the rules in Java is Java 7 code has to run in Java 8. Java 8 code does not have to run in Java 7. So you can always add methods to classes or interfaces, and it won't break your existing code unless you serialize it. Of course, serialization doesn't work across Java major versions anyway. So all your old methods still work. So and this happens all the time in Java. ArrayList has more methods in Java 6 than it did in Java 5. No problem. Is it a default method?
So
I'm just thinking, otherwise, if I took code from Java 7 and tried to compile it under 8, I'd have to update all my list classes to provide it.
You mean if you implemented list yourself? Yes. OK. So this is a good question. So the question was the list interface, was it really an interface or was it an abstract class? If it's an abstract class, no problem. But if it's an interface, if you add a new method to it, all the built-in code would still work fine. But Scott's question is, what if I wrote my own code in Java 7, my own code that directly implemented list? If I wrote my own code that directly implemented the list interface, now I haven't implemented all the methods and it won't compile. But it turns out it's one of these concrete methods, and so you're OK. That's exactly the reason why I do it. It seems strange. If you're going to do multiple inheritance, shouldn't you have multiple inheritance with classes, not with interfaces? Shouldn't you have changed abstract classes to be able to have concrete methods? And the reason they did it with interfaces was for this reason. OK, so you can turn arrays and lists easily into streams. But turning them into is kind of a fuzzy term, as we'll see in the next couple of slides. All right, and then let's look at 5 methods quickly. Call a function on each element of the stream. Who asked me the question about side effects earlier? OK. in this case, if that function doesn't do any side effects, this is kind of useless. So here's a case where it better have side effects or there's no point in using forEach. Map is a transformation operation. Those of you who've done JavaScript and Lisp are very familiar with this already. Given a list of IDs, produce a list of employees by passing each ID through this function and taking the output and collecting it. Filter, keep only the things that match this predicate. Find first, give me the first one. And reduce is about combining things. Map and reduce the ideas that Hadoop, of course, uses. OK, so forEach just says loop down and call this function on each one. Print out each entry, clear each text field. And you say, well, is that really much different than the forEach loop that's already built in? You pass in a lambda, but what's the difference? Well, that's a good question. Arguably, depending on how I put my indentation, arguably the new way is slightly shorter than the old way. Very questionable. It all depends on kind of how I format my code. So that's a little questionable. But the second way is more reusable than the top way. Because this way, which is the Java 7 way, suppose you want to have another loop that does the same thing. You'd have to go and write a method to avoid repeating it. But the second one takes a lambda. You can just assign the lambda to a variable and use the variable in two different loops. So the body of the code, and actually another way of saying that is, what's a lambda? A piece of code that you want to call later. That's another way of thinking about it. And that's exactly what you might want to do here. But here's the really big advantage of the bottom one over the top one. Suppose you take the top one and you want to run it in parallel. Suppose you know that those methods are side effect free. They only do side effects on the individual objects. They don't modify any shared data. OK, you Java programmers, how would you do it? How would you make it parallel? You'd say, executor service task list equals new executor service, executors.new test blah, and then you'd make a runnable inside here and you pass the task list. Basically, you'd throw out this code and you write new code. Now, everything is based on your expectations. So when I came to Java and I was doing BSD threads, Java threads seemed miraculously easy. And then Java 5 came along and they had executor service, and then my old threading seemed even more miraculously easy. And now it seems hard. Your expectations of what should be easy and hard change over time. And so if you do it the bottom way and you want to run it in parallel, you just put .parallel in front. And poof, it runs in parallel. Now, of course, if this accesses shared data and you've got race conditions, you've just made it easier to shoot yourself in the foot. But one of the goals of Java is adapt with the times. Java 8 is adapt with the times. Highly, large-scale multi-core computers are more and more common than ever. My Android device, for goodness sake, has four cores on it. Much less, desktops with 16 cores are very common now. And servers, with 64 cores are very common. And so one of the things they wanted to do is make it very simple to make use of the multiple cores. This is not Hadoop. It doesn't go across multiple computers, but it goes across multiple cores on the same computer. So that's a big boon. All right, so let me give you a couple more examples of the methods. Filter is more or less what we wrote before, except this built-in one is better. Keep the things that pass this test. So given a stream of numbers, keep only the even ones. This funny syntax means turn it into an array at the end. Keep only the ones that are even and greater than 3. Now here's a question. Wouldn't it be faster if I did a single filter and I said, n mod 2 is equal to 0 and n is greater than 3? OK, true. But with an and, Java does short circuit evaluation. And if the first one fails, it doesn't test the second one anyway. So you kind of got that anyhow. So the answer is, if this were lists, definitely combining this into a single filter would be faster. It would use less memory because it's not accumulating it twice. But it can't do that for me with lists. And it can do this for me with streams. That's the key. So combining this into one is no faster because of lazy evaluation. But it would be faster with lists.
It would use more memory, certainly, because it's got to accumulate the intermediate results. OK, Java 8 added this new thing called an optional, which instead of returning null and testing for null, you return an optional. And then you can query the optional to see if it's got a value or not. It's just a minor feature of Java 8. So find first on a stream returns an optional. Because if you did a map where you transform a bunch of things, the old stream has the same number of entries as the new stream. But if you do a filter, you don't know how many things pass. Maybe none of them passed. And so when you do find first, it doesn't return the object itself because it might be null. You don't want to test for null. So it returns an optional, which is slightly marginally better than checking for null each time. That's a minor feature.
Yes, but not getting that null pointer exactly.
But if you do a get and there isn't anything there, you still throws an exception. So if you've done a filter and there might not, if you've only done a map, then there's the same number of entries. There are 10 entries in, there are 10 entries out. So it's safe to do get directly. But if you've done a filter, you don't know. So rather than catching an exception, you say or else. If there's a value, return it. Otherwise, return this new value instead. That's why optionals are slightly more convenient than checking for null. But you still got to plan for it. Oops. OK, wait, what? I skipped map somehow. Where's the map? Here. Yeah. Sorry. Somehow I skipped over the slide. I pressed my thing too hard. This is the most important one. So given a stream of blahs, we produce a stream of foos by passing each blah through a blah to foo function. So this says, given a stream of numbers, return the squares. So the input type and the output type are both numbers. But this one, assuming find by ID is a function that I wrote, whose input is an ID as a number and whose output is an employee, then the second one, the input is a stream of numbers, and the output is a stream of employees. And this is the famous map that you're all familiar with from JavaScript and Lisp and Scheme and Hadoop. OK, and map and reduce commonly go together. Reduce combines things. I'm running a little bit late, so let me just show you there's several versions of reduce, but I think the top one is a little bit more flexible. So the top one says you start with a base value, an identity value. And what it does is it takes the first entry in the stream and that base value, and it passes them through max. And only one number comes out. And of course, this is the smallest possible number, and so whatever number was in your stream is what comes out. And it takes that value that comes out, and then the second thing in your stream, and it passes those things through max. And it takes a number that comes out. It takes a number that comes out, and the third thing in your stream, and it passes them through max. And it takes the number that comes out, and the fourth thing in your stream, and it passes through max. And it keeps doing that until there's only one number left. There's also a version that doesn't start with a initial value, and it just combines them pairwise. But then that returns an optional, because if there weren't at least 2 entries in your list to begin with, there's nothing to do. OK, so let me give you one more example of solid examples of reduce. I've got tons of more complicated reduce examples and more detailed tutorial on my website. All right, so those are all cool methods. But you could kind of imagine writing those yourself. But you couldn't write them yourself in the list interface and give them the same performance. That's the key point. They had to make something new to give it this new great performance. And the most important one is lazy evaluation. So let me skip to this. All right, so you recognize anybody in this list? Who in the, OK, so obviously you recognize the first 3. But anybody else you recognize? Who in here has done Hadoop? OK, so you should recognize those 2 guys. They wrote the original MapReduce paper on which Hadoop was based. And Peter Norvig is the director of research for all of Google. And it was a little scared because when I gave my talk in Mountain View, Peter Norvig was sitting right there. And Google's representative to the Java specification committee who helped design this was sitting right there. So I'm like, oh, man, if they want to hammer me, they can. But fortunately, they were very polite to me and didn't. OK, so don't look at this answer. And suppose that I don't have 5 IDs, I have 500 IDs. And I do this.
take the IDs and turn them into employees by passing them through a function that looks them up out of an array or a hash table or something like this. Then maybe some of those are null, because maybe some of the IDs don't match anybody. So take out the null ones. And then only keep the ones whose salary is greater than 500,000. This is where everyone in the audience burst into laughter and said, that doesn't narrow it down very much here. OK, fine. And then give me the first one. All right, how many times does it call find Googler? How many times does it check for null? How many times does it check the salary? And so say there are 5,000 IDs. Give me a number. Don't look at the answer. Well, Marty, this is kind of obvious, right? So map returns a stream. There's 5,000 IDs. So it calls this 5,000 times, right? Marty does. It's obvious. And then some of them were nulls. But it's got to check them all. So it checks that 5,000 times. But some of those nulls returned it. So now maybe there's 3,000 left. It calls that 3,000 times and returns the first one. 5,000, 5,000, 3,000, 1. But that's not actually what happens. It actually takes the first one, passes it through find Googler, checks if it's null. 16 is not ID, so that doesn't match anything. So it throws it out. Never checks salary. Then it takes the second one, 8, passes it through find Googler. It turns out to be Peter Norvig, which is supposed to be a joke because I knew he was going to be in the audience. And not null. Salary greater than 500,000, yes, by a very, 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 very long shot. And it returns it. And it never even looked at any of the others. You couldn't do that with list, because if you add a new method to list, it doesn't on all of them. So map doesn't really map. The map method doesn't really do the mapping. It adds a mapping operation to a pipeline, but it doesn't execute the pipeline yet. Filter doesn't really filter. The filter method doesn't really filter. It adds a filter operation to the pipeline. So when I call map filter filter, it adds a mapping operation, a filter operation, and a filter operation to the pipeline. Then it takes the pipeline that contains 3 operations and applies that pipeline to 16. And then it applies that pipeline to 8. And the first time something comes out of the bottom of the pipeline, it finishes and it's done. So it had to have a totally different data structure behind the scenes to get this lazy evaluation to work. But look how much, not just faster, but more memory efficient it is. It's not accumulating all the data in between. And if the first one happens to be the answer, it didn't do all this wasted code. And it would be very, 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 very probably impossibly hard to do add methods to the list interface that had the same performance that you could call separately without having to combine them into some big giant loop each time. That's the beauty. It's reusable, but it's fast. OK, so the first cool thing is lazy evaluation. The second cool thing is if you want to make it parallel, you just say parallel. You might not get the right answer. If you're doing reduce and you're combining things, OK, for addition, if you add them up in a different order, do you get the same answer? Yes. For subtraction, if you subtract them in a different order, do you get the same answer? No. Multiplication. For ints, yes. For doubles, no. Technically, if you multiply numbers of a different size next to each other, you could get different round-off error. So technically, if you do a parallel on multiplication for reduce, you might get a couple digits at the very end different, possibly. It is possible in principle. So you're not absolutely guaranteed to get the same answer. So you got to know what you're doing before you start parallelizing things. But if you want to run it in parallel, it's super easy. You don't have to throw away your code and use executive service, much as I love executive service. So easy to shoot yourself in the foot, but if you know what you're doing, super duper duper easy to run code in parallel. And that's one of the goals. OK, so your code is faster because of lazy evaluation. Your code is faster because it's so easy to write code in parallel that you'll do it more. And then finally, there's this cool idea that I'm running late, so I'm going to not go through this whole example. But you can read it on your own. But you can supply a generator function. Either a single function, but it can be stateful, so it can internally remember values, or an initial value in a function, and it just calls the function on the previous value each time to accumulate things. So if you want to, here's a really, really super simple. Oh no, my super simple example is on the website. So I'm not going to go through this example. I'll let you do. But the point is that with list, you got to put the code in ahead of time. So you got to know how many entries you're going to need. But suppose you don't really know. I've got an example here with prime numbers. I have really large prime numbers for some public key cryptography application. I don't know at runtime if they're going to ask for 50 or 50,000. So I don't want to fill the list with 50,000 and then they only use 50. I wasted all that data. So I have a function. And when they ask for an entry from the stream using lazy evaluation, every time they actually need a real value, it calls my function and produces it. But it doesn't produce it until they need it. Okay, and those aren't really infinite streams. They're streams with no preset size. But people like to brag and call them infinite streams, which is a little bit of an exaggeration. Okay, so an example with prime numbers, but I'm running a little bit late here. So, all right, so there's a bunch of online resources where you can get more information. This one little talk, I've got 6 much longer and more detailed lectures with exercises and exercise solutions on my website that I use in a 2-day training course on Java 8, but you're free to grab it and read it and use it as you want. There's a bunch of white papers here. And if you haven't already downloaded Java 8, you should upgrade because it's more expressive, faster, and everybody else is going to be using it anyway, so you might as well learn now. Okay, but this is not something in beta. This is official final release of Java 8, and it's been out for a while, and this is standard Java now. Okay, so first thing is lambdas. And the key point is you can use a lambda where the API expects an interface. The interface has one method. Or more precisely, one abstract method. In Java 7, there was no distinction between those two words, phrases. So you take away the interface name. You take away the method name. You just use the body of the method, and you put an arrow in between. But if you could express it as a single return statement without side effects first, then you can leave off the return statement and just use an expression. You can leave off the types, because there's only one method. Java already knows what the types are. And if the one method of the interface has one argument, you can leave off the parentheses of that argument. Any built-in method you can use just by passing in a method reference, class name or variable name, : method name. When you make your own interfaces, if you're designing for lambdas, you should use this for the same reason you use the @override. It would work with or without it, but it's good. It catches errors at compile time and expresses your design intent. I've skipped over the example that did this, but in anonymous inner classes in Java 7, if it uses a local variable, not an instance variable, a local variable from the surrounding code, you have to mark it as with the declaration final. In Java 8, if it uses a local variable from the surrounding code, it still can't mutate it. It can mutate its own variables. It can mutate instance variables. It can't mutate local variables from the surrounding code. Same rules as in Java 7. You just don't have to mark it with the word final, which is nice. So it has to be final. And if you try to mutate it, it'll give you an error message saying you can't mutate local variables from the surrounding code. But you don't have to put the annoying. I just hated that. I don't know why it bugged me so much.
Can you modify it after the lambda, though? So if you put it in the function?
No, you can't modify. You can't modify it. Yeah, you can't modify it any time after because the function isn't going to be called till later. If you modify it later, what happens? This is exactly the weird problem you come into in JavaScript when you do that. When I mentioned that you don't have to declare it final, but it has to be effectively final, at this talk in Mountain View, some guy in the back with a long beard raises his hand and says, "Oh, does this mean the Java specification committee has finally come to its senses?" Okay, they're recording this. They're going to put it on YouTube, and they're sending it out internally. What do I say? Yes or no? Either way, I'm in trouble. So I just kind of mumbled and didn't say anything.
Yes. So I think the Lambda idea is pretty cool. But on the other hand, correct me if I'm wrong, but I feel like you're sacrificing modularity. So I'm thinking, how am I going to test my like when I'm testing my code? I don't really, because you are pretty much sacrificing the standalone method that is in Java 7, where you create a method that does something and then you call that method, but then that makes that method really modular, even though it's kind of repetitive, but it's very easy to test. Whereas now you have this where it's like you can put anything you want in there, but how's that going to test?
I think you're not quite entirely following the idea. I think this is more modular. So when you define a function in an interface, you define it the same way in Java 7 as in Java 8. It's the calling code where you supply an instance of the class. Okay, and so the place you would have used an anonymous inner class in Java 7, which is one-time code anyway, you can use a shorter version of one-time code. So when you define a class in Java 8, you still write a method the same way you would before.
Oh,
It's whenever you're calling an argument where it expects an instance of a one-element interface, there's a shortcut way basically for defining the method that you're passing in. But if you want to make it reusable, you can still make a class the old way. And so you still should. And so in your example, reusable code still goes in classes. A function that you want to call later goes into Lambda. Okay, so I think it's going to take some practice. JavaScript programmers don't know anything about object-oriented programming. Java programmers don't know anything about functional programming. Now the two have to come together and gradually learn the other technologies and learn which approach is better for which situations. But Java will always be primarily an object-oriented language. This is not trying to turn Java into Lisp or Scheme or ML or Haskell or Miranda or even JavaScript. But there's a number of strategies and approaches, some of which I try to illustrate, where functional programming is more natural, easier to understand, more flexible, more reusable. And the streams is a perfect example. All of those are so much more useful by being able to pass in Lambda than if you had to pass in an instance of anonymous in your class. You just wouldn't have bothered to use streams in that case. OK, so Lambdas, there's a bunch of reusable functions. You could have written all these reusable functions in Java 7, but it wouldn't have been so useful to do so. But the fact that you can use predicate in filter as a Lambda. You can use function in map as a Lambda. You can use consumer in forEach as a Lambda. And you can use binary operator in reduce as a Lambda. So you can use Lambdas for instances of these. It's what makes them so useful. And streams are kind of like lists, but a lot of cool methods and cool properties. So not only cool methods, but these methods are much faster and much more memory efficient than anything you could have ever put into the list interface, because they support lazy evaluation. That's the most important one. Second most important is because you can turn them into parallel code automatically without having to throw away your old code and rewrite new code. And this is kind of cool, but not nearly as important as the other two. You can have unbounded lists where you don't have to put real data in them ahead of time. All right, so we got good news and we got bad news. And this one really is me at the Taj Mahal. That one's not really me at the Terps game, but that's the best I could find. I have pictures of me booing. So yay, we got Lambdas. And maybe this is not as good as Lisp has Lambdas. Fine, it'll never be as good as Lisp. Scheme programmers will never be satisfied with anything Java does. Face it. OK, they won't. That's fine. But it retrofits to the existing APIs. That's the beauty of it. I argue they should have put functional programming in Java at the beginning. They didn't, but given that they didn't at the beginning, this is about as good as we can probably do. And it's pretty darn good. OK, maybe it's not real functional programming. And the biggest downside is there's not a function type in Java 8. In JavaScript, anytime you have a function, you know how to call it. In Java 8, anytime you have a Lambda, you have to know the real interface it turns into and the real method name. The calling code doesn't have to, but the using code has to. And whether or not this really defined term as functional programming is highly debatable, but some people think so. You still can't mutate local variables just like you couldn't in Java 7 in anonymous interclasses. OK, it's a lot more information online. All right, any other questions? I've got 10 minutes before our scheduled departure time, so I'll take 3 or 4 questions, and I'll just break. And if you have more questions, I'll take them individually.
Dead tree resources? Do you have
can we please use the microphone for the question?
Yeah, or I can repeat the question if you want.
Books, a book to go back over some of these points.
OK, so there are right now, I list them on the website, but I don't have them listed here. There are right now 2 books published on Java 8, and only 2. There's Java 8 for the Really Impatient by Kai Horstman. And there's Functional Programming in Java by Venkat Subramanian, both of which I were reviewers for. And those are the only 2 that are out so far. But very soon, the next release of all the Java books will all cover it because it's part of Java SE. But they're not out yet.
What's the difference now between an abstract class and an interface?
Well, this is a good question. I think if the Java, so the question for the remote audience is, what's the difference now between an abstract method and an interface? Because interfaces can now have concrete methods. And I think if the Java designers had known they were going to do this, they would have just put multiple inheritance in the language from the beginning. but they didn't know, and for the reason Scott Stanchfield said, to make the existing interfaces that they could add methods to it without breaking your old code that implemented the interface directly, they had said, oh, we're going to add concrete methods to interfaces. And so it's kind of weird, you know, and so in some ways they kind of seem like the same thing. They can both have abstract methods and they can both have concrete methods. And the big difference, though, is multiple inheritance. You can implement multiple interfaces, you can only extend one abstract class. And so in some sense, for your new code, you never need abstract classes anymore. There's no purpose. Although there is one difference. Although interfaces can have concrete methods, they can't have instance variables. But for the most part, for new code, you don't need abstract classes anymore. And it's kind of a weird way of doing it, and they wouldn't have done it this way if they'd done it from the beginning. But it's some sort of legacy hoops they got to jump through. So interfaces are great now, but what's the purpose of abstract classes then? Oh well. But of course, all your existing code with abstract classes still works the same way it always did. OK, little break here. If you've got any other questions, I'll take them individually. And I think my email address is here. So if you've got, every time I give a talk, somebody says, can I send you some Java 8 questions later? And my answer is always, how the heck am I going to stop you? Right? Of course you can send them to me. Will I answer? And yeah, I'll try to answer. But if you send me a Java 8 question, which I'm happy for you to do so, just put the word Java in the subject line, because I've had this email address since the first, I kid you not, since the first 30 days that Johns Hopkins University had named email addresses. I had this email address, I'm going to give away my age here, but I had this email address in 1984. So every spammer in the world has that email address. And so if you send me a Java 8 question and your subject line is blank, or even if it's question, or if it's cheap drugs from Canada, it'll go into my junk box and I won't see it. So just put the word Java or Java question or Java 8 question. But if it's got the Java in the subject line, I've got a filter that flags it as, and puts it in red. OK, let's break there. And if you got other questions, I'll take them individually. And thanks for having me. And I hope to attend other of these tech talks. I know Scott's giving one, and I hope some of the other will give one. And I look forward to attending those.